So next up, let's make a relatively simple guessing game. This is a demo of how it will work when it's done. So it starts by asking us to enter a maximum number. So basically a difficulty. Let's go from 0 or 1 to 20. And then I need to enter my first guess. Let's go with, 10. That's too low. So it tells me I need to guess again. Okay, so let's try guessing higher. How about 15? Too high. 13. Too low. 14. And then it tells us it took you 4 guesses. Also, if I refresh and I try entering, a really large max like 1,000, it could take me a long time. So if I'm getting frustrated with that, I can type Q, and I just quit the game immediately. So let's try building it. The first thing I want to do is ask a user to enter in their maximum number. So if we're going from 1 to 10 or 20 or 50 or 1,000 or whatever it is. So I'm going to prompt enter your, the maximum number. And I'll save that to a variable. So we'll go with let, and I'll tell you why I'm using let in just a minute. Maximum equal prompt. You would think this doesn't need to change, right? It's a one-time thing, and then we should just take that value and save it. But there's a possibility that I enter something in that is not actually a number. Well, everything is going to be a string technically, even if it's 3. It needs to be converted into a number. And so if I try and call parse int, which is how we're going to do that, on something that is not a number, we get not a number. So it will work on things that can be converted, even like that contain an integer. So I just want to check and make sure that a user has actually entered something in that is valid and that can be parsed. So I am going to parse it here, parse int. Just do it on the same line. Parse int on whatever we got from prompting the user. And then let's assume that it works to start. Let's assume that that's a fine number. It's, it's 90. How do we generate our random number from 1 to 90? Or 1 to whatever maximum is? Well, remember how we generate a number from 1 to 10. It's math.random. We multiply by 10, and then we floor that entire thing, and then we add 1 at the end. So we're going from 0 to 1 as a decimal. We multiply by 10. Then we chop off the decimal. And then we add 1. Okay? Now this is going to give us 1 to 10. But if I want 1 to our maximum, it just looks like that. So let's save that in a variable. Const target num. This is what we're trying to guess. And let's just console.log it so we can see it. Console.log target num. All right, so I'm going to refresh. Enter our maximum number. Let's do 4. Ooh, maximum is not defined. What did I call this? Oh, well, I can't spell. Wow, there we go, maximum. Try that again. We'll enter 4. Okay, so the random number was 1. If I enter 1,000, the random number is 643. If I enter a much larger number, there we go, we get a much larger random number. So technically, we're not really testing to see that the entire range is working. We're just picking one random number. But there is a problem, which is if I enter something that is not valid when we parse it, I get not a number as my random number, because parse int gives me not a number, and I'm multiplying by not a number, so the end result is always not a number. Anytime we do math with nan, we get nan. So I want to make sure that we actually get a valid maximum that is a number before we move on to this line. So I could just do this if there's not a maximum. Remember that not a number is falsy. So I'm checking right here. If maximum happens to be falsy, why don't we just get this line again? Right, I could update maximum. How about enter a valid number? So I could do that. So I'm going to enter something invalid. Please enter a valid number. Okay, and that works. If I enter something valid right away, we skip that step. But the problem is we're only checking one time. So I could enter something incorrect, invalid, like that, and then again, and we move on. But that's not what I want to do. So I'm going to use a while loop. I'm just going to replace this. While there is not a maximum number that is valid, so while there's a falsy max, just update max and keep asking. So why don't we console.log target number again? I don't know why I got rid of that. Now take a look. Not valid, not valid, not valid. We're all stuck in that while loop. And now I'll enter in something that is valid, and we're good to go. Cool. So that's the first step. We have now made it so that a user has to enter in a valid number. Technically, this also screens out 0 because 0 is considered falsy. And we're not going to worry about negative numbers for now. All right, so now I want to actually make the game. So now that you have picked your number, the maximum number, and we have our own random number, your target here, what we want to do is ask you to enter a guess. And then as long as that guess is incorrect, we're going to tell you if it's too high or too low. So to get that guess, we could just prompt you. Let guess equal prompt. Enter your first guess. Cool. And then we'll write our while loop. While your guess is not equal to target num. But there's a problem here, which is that your guess is going to be a string, and we're comparing guess and target num, which is a number. Those are not going to ever be equal, or that's going to be problematic for comparisons. So I could parse int like this, as we've seen. Cool. So we're parsing your prompt, whatever you enter, and while they're not the same, let's check. If your guess is greater than target number, let's prompt you again. Too high, enter a new guess. And save that to our guess variable. And then otherwise, we'll do too low. Because if we're in this loop at all, right, if we've made it into this loop, we know they're not equal. So it's either greater or less. We don't have to worry about the case of equality. And let's just at the end down here, do a console.log. You got it. Let's see what happens. Hopefully no infinite loops. Oh, there is going to be a problem actually. We're parsing it one time, but then assuming you don't get it right on the first guess, we're going to ask you again, enter a new guess, and we're not parsing int. So we could do this here, parse int on both of them, just like that, and then parse int over here. Let's see if that works. So, oh, I need to enter a valid number still. Enter a max. Okay. So, what is our maximum number going to be? Let's go from 1 to 10. My first guess will be 5, 7, 9, 10. Oh, it happened to be 10, and it ends. All right. So that seems to be working. The next thing I want to do is, well, there's really a couple things. Let's keep track of the number of attempts that it takes you, the number of guesses. So let's create a variable. Let's just call it attempts. And it starts at 1 because that's the bare minimum, right? You've already made one guess. We'll start it at 1. And then every time you make it in this loop, we just add 1. We could do plus equals 1 or just plus plus, because the fact that you've made it into this loop means that you're guessing again. And then at the end, we can do you got it. Let's do a string template literal. So we'll say like, you know, it took you 5 guesses or 10 guesses. You got it. It took you. And then $ attempts. And we're not going to pluralize correctly, so I'll just say guesses. We'll assume it took you more than 1, but there's a chance you get it right on the first time, and it will say it took you 1 guesses. It should be 1 guess. So let's see if that works. So my first guess, 5. Too low. First guess, 5 again. Too low, 10. Too high, 8. Too high, 7. 6. Okay, 5 guesses. Awesome. Now, the last thing I want to add in here is the ability to quit early, because I could enter in a very large number, like 1,000 or 10,000, and I could be here for a while trying to end this game. So to make that work, all that we'll do is check to see if your prompt at any point is equal to Q, or quits, or something like that. So if guess equals Q, how do we get out of this loop? We can break. But there's a problem with this approach as it stands. Guess is never going to be Q, because I'm parsing int as soon as we get your prompt. So even if you enter Q, I parse int, we get not a number. Now, there is a way around this, which is that we just don't parse int right away. We'll save your input, the result of prompt, as a string, and then when I compare the guess to target number, I can parse int then. This is just one approach at least. So if I enter Q, that's fine. It will stay in our variable guess, and then we can parse int here, but we're not actually changing the variable guess. We're just parsing it, see what it looks like, compare it to target num, but if it happens to be Q, it still stays Q in the variable itself. So let's verify that. I'll enter in a large number, 100. I don't want to deal with this. So I'm going to type Q, and I get out of there. Technically, yeah, it's going to tell me you got it. It took you 3 guesses. We could add a little conditional at the end. We could do something like if guess equals Q down here. We can console.log, okay, quitting, or okay, you quit, or something. Otherwise, we'll display congratulations, you know, this sort of thing. Maybe 2 console.logs. Console.log, congrats, you win. Okay, so we're just checking to see what guess is equal to after this entire loop finishes. Let's try one more. So let's go to 40 maybe. My first guess is 20. Too high. How about 10? Too high. 1. Too low. 5. Congrats, you win. You got it. It took you 4 guesses. Now let's do the same thing. 1 to 100. My first guess is 50. Too low. Let's just enter 2. Well, that makes no sense. But let's quit. Okay, you quit. And we're all done. So this combines a lot of what we've learned so far. Conditionals, a while loop, another while loop up top to make sure we're getting valid input, as well as the break keyword. So that's our simple guessing game.